Hi everyone, welcome to the Digu Science channel. This is the first video in the electromagnetic induction series. One of the most influential figures in this series is Michael Faraday. Faraday was the first to propose the concept of magnetic flux. In simple terms, we can define magnetic flux as the number of magnetic lines of force that penetrate a surface perpendicularly. Read this definition again carefully. This definition contains several key words: lines of force and penetrating the surface. Let's start with lines of force. Here is a cylindrical magnet. In this series, on the physics of magnetism, we learned that a magnetic field exists around a cylindrical magnet. The lines that describe the magnetic field around an object are lines of force. This is because these lines have a direction. They run from the North Pole to the South Pole. Imagine that in a certain space, there are magnetic lines of force running from left to right. There are 8 lines of force. In front of these lines is a surface. The front of the surface looks like a rectangle. This surface will eventually face the lines of force perpendicularly. All lines of force can penetrate the surface. Now, the surface is tilted at a certain angle. The number of lines of force penetrating the surface is reduced to 6 units. Tilt the surface again. It turns out that only 4 lines of force penetrate the surface. When the surface is parallel to the horizontal plane, no lines of force penetrate the surface. The number of lines of force that penetrate the surface is referred to as magnetic flux. We now know what magnetic flux is visually. So, how do we express the value of magnetic flux quantitatively? In physical analysis, a surface has several vectors. One of these vectors is perpendicular to the surface. We often call it the surface normal. This vector, whose magnitude is the surface area, is directed normal to the surface. We can shift the magnetic field vector so that the origins of the two vectors coincide. The angle formed by these two vectors is beta. Magnetic flux is the product of the surface area A, the magnetic field B, and the cosine of the angle beta. To distinguish it from electric flux, we can add the subscript B after the magnetic flux symbol. This is the mathematical equation for magnetic flux. Hopefully, this short tutorial has provided an overview of magnetic flux. And don't forget to watch the next video.